Hello, everybody. A warm welcome from my side on the Grace Hopper stage at the second day of the Big-Data.AI Summit 2022. My name is Lukas Klingholz. I'm responsible for cloud and AI at Bitkom, and I'm your moderator for the next 3.5 hours. And I'm very happy to directly introduce the first speaker on the Grace Hopper stage today, which is Krupakar Singampally. He is practice lead for advanced analytics at Infosys, and he's talking about AI-based forecasting for B2B manufacturers using Amazon Forecast. The stage is yours.
Thank you. I'll just start sharing my screen here. I hope you're able to see the screen.
Yes, we can see the screen. Perfect.
Great. Good morning, everyone. I'll be speaking to you about a recent program that we executed for a manufacturer in the US. Let me jump directly to the context of the case. Yes, minimize the screen here. Yeah. So this is a global HVAC company that is an air conditioning chiller manufacturing company. It's a leading company across the entire world. And they were looking to execute a AI-led supply chain transformation, starting with demand forecasting. The intention was, as we improve the forecasting that we do, the accuracy of forecasting, it gives us greater opportunities for inventory optimization, reducing lost sales, and further optimization down at the factory level in terms of resource planning, etc. This particular stage of the program required us to build a fully automated, at-scale AI-based solution for demand forecasting across 34 different product groups and hundreds of stock keeping units. Let me give you a few more details about the business problem and the value proposition. If you see the top part here, let me just grab my pointer. If you see the before we did the program, the way demand forecasting was being executed across a variety of very distinctive brands, none of which have, they all have very different kind of drivers, was manual. The forecasting was being done by a couple of demand planners in Excel sheets. It was qualitative, judgment driven. They were using industry parameters and various kinds of indices, but it was all up to their judgment on how they use that information. And it was primarily driven by the historical sales trends. As a result, the demand that emerged was the plan that emerged was inaccurate. The forecast was inaccurate to the extent of about 35% of average error across all of these brands and SKUs. And that resulted in the manufacturing centers, there would be a lot of waste because you are over ordering or under ordering your raw materials. And there were also these kind of outcomes that you see here. Many of these products were also made to order, and because the raw material procurement was driven by this demand plan, the cycles of time to fulfill a made to order was in the order of months. So if a customer places an order, it takes several months for that product to be delivered to that customer. From there, we have moved to this forecasting where we are not only using historical sales as quantitative data, but also demand drivers beyond just the trend and seasonality that is evident in the historical sales. And we were looking at external factors which were being considered here, but qualitatively. Now we were taking them as quantitative inputs into an AI model, which the details of which I'll speak to in subsequent pages. And as a result, we improved the accuracy of the forecasting to 20% from a 35% average. I also should mention this 35% average was at a category level, whereas we achieved 20% average at the SKU level, a level lower, which is always more advantageous. And then if you see the breakup in terms of made to stock versus made to order, the forecast improvement that we did was in the order of 44% and 11%. And the outcomes that we expect are these, that we get more predictability. And ultimately, the business value that the client is looking for is in these kind of factors. Now, let me go a little bit more into the detail. Before I go into the modeling approach, I just wanted to mention a few challenges that we interesting challenges that we had to deal with. As I mentioned earlier, they were a good mix of made-to-order products. Made-to-order is inherently harder to forecast because they are tailor-made to customers and their demand is lumpy and intermittent. That presented a challenge for us. There's also this all this forecasting that we were doing were in the context of B2B sales, that is industrial customers. This is not retail. So aspects such as promotions, competitor activity, etc., are much harder to gauge and account for, and the demand profiles of these products were very different from each other. Some were very frequent, some were erratic, lumpy. That is, the demand would occur in big lumps, and then there would be long gaps, and intermittent. And we also had to account for COVID effects because we just completed this program and it was being executed during the COVID pandemic, which means that the demand was behaving quite erratically. If you see the actual sales pattern across the entire year of 2020, it was very erratic. What was our solution approach? If you see, the inputs that we considered were the historical sales data. So this sales data was being provided to us at an SKU level, and we had the last 3 years of data that we were considering into the model. And then we considered a variety of external indices for informing the model. The AHRI is the industry level index that tells you at an industry level for the air conditioning industry how many products are being sold month on month. Dodge tells you what is the construction awards that have happened in this month, which is the new buildings that are going up, which has a correlation with the kind of industrial air conditioning and chillers that has to go into production. HSPU gives you the non-commercial construction right now that is already existent. Wholesale price index, the industrial index of production, GDP. I assume that they are obvious. And we also considered things like percentage of cold areas and warm areas, but they turned out to be not so relevant because this is really industrial ACs, which are not driven by, whether the need for climate control is not based on a local weather pattern. The most correlated factors that we saw were these, the HR and Dodge, but all of these factors ultimately went into the model. And the model itself, if you look at the models that we used, we looked at Amazon Forecast. Amazon Forecast is a service provided by Amazon that provides these models out of the box. Some of them are neural networks, some of them are time series. I have a slide that explains this better. But what Amazon provides you is this suite of models against which you can train this data and get predictions. And we use these as features. For instance, price category, like a premium product versus a basic product would be evident from the price category. The marketing category represents the broad nature of use of these products, whether it is chiller or whether it is a gas-based chiller, etc. External indices that I already mentioned. Demand profile, as you can see here, would be determining whether it's a smooth, erratic, etc. And that has a big bearing on the prediction model that would be selected. And for each of these products, which is the dominant customer industry and the secondary customer industry that would consume these products, that is another factor that we considered. So it could be education, it could be hospitals, it could be malls, etc. All of these would enter into the consideration. And we, on top of the forecasting model that Amazon provides, we did this feature selection. This was something that we had to do discretionarily, as well as this champion selection that the Amazon forecast doesn't provide. What it means is that at any point of time, we are training all 6 models on all the history of data and selecting the best one of these based on a validation period for an individual SKU. That means for each individual SKU, a different model would be used based on the demand profile of that product. The most suitable one would be used, and that allows us to get the best out of these models. We also did a lot of hyperparameter tuning for these models, and the output was an SKU level forecast. A little bit of an introduction to Amazon forecasts. Deep AR Plus and CNN QR are two neural network based models. They're very useful because they learn from a group of SKUs. Normally, any kind of machine learning model is based on individual SKUs time series, whereas here it looks for patterns among the group of SKUs and learn for each SKU, and hence it can support new product introduction scenarios, because if you introduce a new SKU, you can still forecast for it because it's going to learn from the patterns of the group. And it has powerful inbuilt lag and seasonality features, such as the one that you see here. So depending on the frequency of your time series, for instance, in our case, we were doing it at a weekly level, it would generate derived features internally, lag features that allow you to forecast better. They are auto tuning, and they also support related time series data such as the indices and various other kind of categorical inputs like the ones I was mentioning in this, can be used to group these SKUs further and learn from that. Apart from that, there are machine learning models and time series models as well. I'll not go into the details of it. Now, once we did the forecasting, what I told you about is the core forecasting approach there, but it was much beyond forecasting. What we needed was an end-to-end automated ML pipeline. So that is where we looked at creating this multi-stage model. The main intention of this multi-stage ML pipeline was on provenance tracking, so that at any point of time, when we do a forecast, we are very clear on what is the kind of transformations of the historical data that were performed to arrive at this forecast, in case we need to reverse engineer that and explain why a certain forecast is behaving this way. Reuse, because we want to make sure that whatever pipeline that we built can be easily scaled to other business units, other geographies. We made this pipeline as clean and modular as possible, and maintainability. As you can see, what we did was a stage two enterprise transformation, where there was a data processing pipeline that would look at data cleansing and converting the raw data to the enterprise data format and merging the external data with the sales data. As a result, what you get is the enterprise level formatted data, which we then convert into an analytical layer, which is ready for processing by Amazon Forecast. So this is where it is available in exactly the same way that Amazon Forecast would want it. So after we have this, we would subject it to the forecast pipeline, where we do a train test split, we would do a champion selection, we'll generate a rolling forecast, and then we persist that forecast. And we allow the user to interact with these forecasts through a workbench and a workflow. And we also have a MAPE calculation or a performance calculation module that allows us to continuously monitor how our forecasts are doing. So this end-to-end pipeline was also implemented as part of this transformation exercise. And was all done on AWS, as I'm showing you here that the raw data lake, which I explained in the previous slide, was in S3. The enterprise data lake was in Snowflake, and the analytical data lake, which is getting ready to provide the data to Amazon Forecast, was again in S3. And the Amazon Forecast service itself is an API call. And then we store the results again back in this enterprise data lake so that it can be used for further analysis. We do a performance assessment based on how these forecast results are versus the sales data that is coming in from SAP. And we show all of that in an Angular JS application that allows the user to update and view these forecasts. So that, that was a quick overview of what we did there. What I will do is, instead of talking further on the content here, I would open up the session for questions.
Until here. And we have a few questions in the chat. I'll start with the first question I see in the chat. Is from Sofia Trojanowska. And she asks, I'm just reading into you, Dear Mr. Krupakar, what is the most important product that Infosys is providing in Germany and Europe, and how do you see the development of the IT demand of German manufacturers and chemical companies?
So Infosys provides a variety of analytical products. I assume, Sophia, that we are talking about products that are relevant to the kind of forecasting that I'm talking about here, or for AI services. So we have a variety of accelerators, such as the champion logic that I was talking about in the previous slide. a variety of computer vision related solutions that manufacturers can use for doing defect identification and other kind of use cases in the factory floor. And we also have a couple of platforms that allow you to do data science at scale using standards. We call it the analytical workbench. So using that analytical workbench, you're able to execute data science in all aspects of the data science lifecycle in one platform.
Thanks a lot. We have two more questions I will just address to you. The next question is regarding the database you use for your sales prediction, to train your models. And the concrete question is, do you have examples or do you have insights in how much sales data is needed, like to develop models which have a good prediction level?
Yeah, in this case, I think there were two questions. One was about the database and then the kind of data series that you need. The databases I'm already showing on screen here. In this particular implementation, we used a combination of S3 buckets and Snowflake as the databases. The reason for these choices, S3 was because it is the default data lake of AWS and it is cheap, easily scalable, and the perfect solution. Snowflake, because that was their the client's enterprise standard for an enterprise data warehouse, and they wanted all of these key measures that were generating out of this forecast to be stored in that enterprise data warehouse. So that is the answer to your database related question. The other question was, how much data do you need to make an accurate forecast? I think in this case, we use 3 years of data. That's ideal because anything beyond 3 years is not very useful. The sales trends change too much over the period of time. Anything less than 3 years is manageable. We have done forecasting for other clients, even with 1 year of data, but 2 to 3 years is ideal for us to capture seasonality patterns.
Perfect. So I will just follow up one question from my side, and then I will ask the last question. So are you agnostic if the customer wants to use another storage approach or another data lake approach, or are you aligned always to Amazon S3 and Snowflake?
No, absolutely not. I mean, we have executed similar solutions on other clouds as well. For instance, for another client, we have executed a very similar solution. In that context, it was returns forecasting rather than demand forecasting, and that was done on GCP, and the whole choices that GCP provides, such as BigQuery and Cloud SQL, and we have similar implementations on Azure as well. So it really all the cloud providers provide you wonderful options in terms of storage and powerful forecasting solutions as well. We mix and match what is necessary for the context of the client based on their requirements.
Perfect. So I have two other questions which I will combine in one question, addressing it to you. The first question is regarding team setup. How many people do you need for such a development of a specific prediction model, and which roles do you see in such a project? And this combined with the question regarding time you need for fine-tuning the parameters of the model and select the best model.
Okay, so team structure-wise, we had a program manager because this program required extensive coordination with the business users, with the IT infrastructure providers of the customer, and their data science team. So program management was a key element. And then we had a core team of data scientists, which is about, I think, 3 to 4 people, one senior data scientist and 3 data science analysts. And we also had a team that was able to develop the AngularJS application, the workflow. It was a complex workflow. That was about 3 people for doing the front-end web development. And maybe and 1 or 2 other people who are taking care of the data engineering aspects of the end-to-end flow. So overall, about 10 people was what went into this kind of program. I'm sorry, I missed a second part of the question. Could you repeat?
No problem. Just a few considerations regarding time you needed for fine-tuning parameters of the model.
Okay, that's a good question. I think the core models we developed using Amazon Forecast within 2 months from the start of the program. I think we spent about the next 3 months really in terms of fine tuning, because we wanted to first of all make sure that Amazon Forecast is indeed the best choice. So we created other models such as XCBoost, Random Forest, which are not available in Amazon Forecast, just to check that we indeed have the winner in Amazon Forecast. And then we spent a lot of time identifying the kind of features that I talked about here, all of these features in fine-tuning these models. So I would say 2 months for the base model and another 2 to 3 months for fine-tuning.
Thanks a lot, Mr. Singampally, for the insights, and thanks a lot for the discussion.